Looking to power your shed, workshop, or off-grid cabin? Instead of trenching and running expensive wiring from your main house, we estimate that trenching would cost anywhere from $1,500 to $5,000, and a solar system would cost anywhere from $1,500 to $3,500. You can set up a solar-powered system using this 3,500-watt all-in-one inverter and a 48-volt LiFePO4 battery. This setup will let you run lights, power tools, and small appliances, all without grid dependence. Let's go step by step through the components, setup, and installation so you can get your off-grid system up and running. To build a small but powerful solar system, you'll need these key components. First, solar panels. We recommend 400 to 800 watts total, using monocrystalline panels for maximum efficiency. Mount them on a roof or ground rack facing south. Ideal size, 2 to 4 200-watt panels for balanced output. Next, a 3,500-watt all-in-one inverter. This comes with a built-in MPPT charge controller, so no separate unit is needed. It provides a 3,500-watt pure sine wave output, which is safe for sensitive electronics and works with 48-volt battery banks, making it more efficient than 12 or 24-volt systems. The AC output terminals allow you to connect directly to loads in your outbuilding. Then, the LiTime 48-volt 100 amp-hour LiFePO4 battery with a 4,800 watt-hour capacity. It offers high-energy storage for longer runtimes, has a lifespan of over 10 years, and requires no maintenance. Plus, it supports multiple batteries for expansion. Finally, you'll need cabling and grounding materials. This includes PV wire, battery cables, AC wiring, a grounding rod, and breakers and fuses. PV wire, typically 10 or 12 AWG, connects the solar panels to the inverter. Battery cables, usually 2 or 4 AWG, link the battery bank to the inverter. AC wiring, 12 AWG for 120-volt loads or 10 AWG for 240-volt loads, connects your AC output. Consider a small panel box to wire the building. An 8-foot copper grounding rod is essential for safety, and breakers and fuses protect circuits and prevent overload. Now, let's walk through the step-by-step installation, focusing on electrical connections, grounding, and cabling. Expect the setup to take around 4 to 6 hours, depending on experience. Step 1. Secure the battery and inverter, which should take about 30 minutes. Mount the 3,500-watt inverter on the wall, ensuring proper ventilation. Place the 48-volt LiFePO4 battery in a secure, dry location. Connect the battery cables, 2 AWG, to the inverter's DC input terminals, and use an inline fuse, 125 amps, to protect the battery connection. Step 2. Connect the solar panels, which should take about 60 minutes. Run PV wire, 10 AWG, from the solar panels to the inverter's solar input. Use an MC4 connector tool to ensure tight solar panel connections. Check polarity, positive to positive, negative to negative. Turn on the inverter's charge controller and confirm solar input. Step 3. Grounding the system, which should take about 45 minutes. Drive an 8-foot copper grounding rod into the ground near the outbuilding. Run a 6 AWG ground wire from the inverter's ground terminal to the rod. Ensure the battery and breaker panel are also grounded to the rod. Step 4. Wiring AC loads, which should take about 60 to 90 minutes. Run 12 AWG wiring from the inverter's AC output to a breaker panel. Install outlets and switches inside the outbuilding. Use an inline breaker, 30 amps, to protect circuits. Step 5. System test and activation, which should take about 30 minutes. Turn on the battery and inverter. Check solar input and battery charging on the inverter display. Plug in a test load like an LED light or drill to confirm AC output. Monitor the system for any wiring issues. Now that your system is up and running, let's look at what it can power and how to expand it. LED lights and fans runs for days on a full battery. Power tools like drills, saws, and sanders handles up to 3,500 watt loads. Appliances such as mini fridges, coffee makers, and laptops. Perfect for a small workspace. Security cameras and Wi-Fi routers. Ideal for an off-grid surveillance system. With this 3,500 watt all-in-one inverter and a 48-volt battery setup, you now have a reliable off-grid power system for your outbuilding. No trenching required. Whether it's for a shed, workshop, or tiny home, this system is a cost-effective way to get energy independence. If this helped you, hit like, subscribe, and drop a comment if you have questions. Thanks for watching and happy solar building.